Okay, so I have verified that my sound is on, so you should be able to hear me now. So this is going to be an epsilon delta proof. So we're going to prove that the limit as x approaches 2 of minus 2x plus 3 exists and equals minus 1. So of course, using theorems, it's a polynomial, which is nice. So for lines and polynomial, which is a polynomial, we can just plug in. And if I plug in 2 here for x, minus 2 times 2 is minus 4, plus 3 does exist and equal minus 1. First of all, I'm going to draw a picture of this. Now, if I draw a picture of this, we have a y-intercept. If you plug in 0, I get 3. So I'm up here on the y-intercept. If I plug in 2, I'm going to get minus 1. But anyway, we have this line through here like that. And basically, we're going around 2. And we want to show that the limit L is minus 1. Of course, 2 is my A, right? And so basically, let me see if I can change colors here. It's not letting me change colors for some reason. But anyway, so I don't really need it. But for any epsilon window around L, if I reverse map it back, I should be able to come up with a delta window around 2, such that every x value maps to the line within that epsilon window. So anyway, but this is what we want to prove. So the first thing that we have to do is we have to let f be defined. So what is f of x? F of x equals minus 2x plus 3, be defined on what? I, some open interval containing a, except possibly a itself. Well, that we can just note the domain. So this is the first part of the definition. The domain of f is all real numbers, which is an open interval because that's negative infinity to positive infinity. So we have that satisfied. It'll contain every a, not only any a, but of course any a equals 2 is going to be part of that all real number open interval. So we're good on that. So that's the first part of the definition. We satisfied that. Now let's go to the let set. So I'm going to, but before we get to that, we got to do some scratch work, right? So let epsilon be greater than 0. We need to find a delta greater than 0 such that what? 0 is less than the absolute value of x minus a. In this case, that's x minus 2 is less than delta, would imply or guarantee that the absolute value of f of x, which is minus 2x plus 3, minus L, so minus in this case, a minus 1, is less than epsilon. So of course, minus a minus is plus a plus. Hey there, I've got my other colors showed up now. So I can do plus a plus here. And really what I can do is work with the finish line and try and come up with my delta over here. So I'm going to work with this. I'm going to simplify it. So what does that imply? That implies the absolute value of minus 2x and then plus 4 is less than epsilon, right? So then what I can do here is I can factor out a minus 2 inside of there. And if I do that, I'll get x minus 2 is less than epsilon. And of course, the absolute value of a times b is the absolute value of a. Let me write this. So that's the absolute value of minus 2 times the absolute value of b, which is the absolute value of x minus 2 is less than epsilon. Well, of course, we know that the absolute value of 2 is just 2, right? So that implies that 2 times, man, it keeps switching the size on me, not you, but that's 2 times the absolute value. Come on, let me write. 2 times the absolute value of x minus 2 is less than epsilon. So then what can we do? We can divide both sides by positive 2. The inequality stays the same because I'm dividing by a positive number. And we can see that what I have over here, the absolute value of x minus 2 is less than delta. We basically have that there. So we're going to let epsilon over 2 equal my delta. Okay, and then we're going to work this on back up. So we're going to do the let set and then rework that bottom up. So I'm going to do this on the fly. This is where I need a bigger board, but I don't have that right now. So let me go back. So for the proof, we already showed that the domain of f was all real numbers. So we had that. We have an open interval. And then we're going to let set. So let epsilon be greater than 0. So that's some tiny positive number. Come on, buddy. Quit moving around on the screen. Let epsilon be greater than 0. Set delta equal to what? It was epsilon over 2. By the way, it's epsilon over the absolute value of m, where m is the slope of the line. So the slope of the line that we have is -2. The absolute value of that is 2. So really, I've already given you a formula with our general proof for the limit of a line, that epsilon over the absolute value of m is going to be what the delta is. But we have the work to do it so that you can undo it bottom up. So then what do we say? 0 is less than the absolute value of x minus a, which was 2, is less than delta. Well, what does that imply? I'm just going to work with the right half here. That implies that the absolute value of x minus 2 is less than, and instead of delta, I'm going to plug in epsilon over 2, right? So this is less than epsilon over 2, and then I'm reworking those steps I had on the previous page bottom up. So now I can multiply both sides by 2. So 2 times the absolute value of x minus 2 is less than epsilon, which implies the absolute value of -2 times the absolute value of x minus 2 is less than epsilon, which then implies I can bring that inside. The absolute value of a times the absolute value of b is the absolute value of a times b. So undoing that, it's less than epsilon, which implies that the absolute value of -2x plus 4 is less than epsilon. Come on. Oh, goodness. Let me write again. It's changing the screen size on me, so you guys can't see this, but it's like going big and little on me, driving me absolutely bonkers. But anyway, that's epsilon there, which implies the last step. So it's -2x plus 3, I believe, was our function. And then minus a -1 is less than epsilon. So once again, this is, to use different colors, this is f of x minus L, right, is less than epsilon. Therefore, what we can say is the limit as x approaches 2 of -2x plus 3 does exist and equal -1. So we're done. So normally I would put a big check mark at the end of that, but basically we used our scratch work to come up with the delta here, and then we used reverse order back up from kind of the right half of this inequality, replace that delta with epsilon over 2, and then reworked our steps bottom up here as we went along here with the implications. Okay, so that's an example of one that's a little bit more awkward because it had a negative slope to it, but don't let that bother you. You should be good to go on that. And if you got any other questions, let me know. Thanks.